Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Talking about similarity in right triangles, we're not talking about like one right triangle is congruent to another right triangle or similar to a right triangle, as in that they're completely separate entities. We're talking about what happens if we take a right triangle and we've got a right angle here, correct? And we go ahead and we draw one of our altitudes. So if you remember, an altitude is going to come through the vertex and meet the other side at a right angle. I'm going to kind of cheat here and use a little square edge here. So we're talking about this particular spot right here. As you can tell, it does not split the hypotenuse into two perfectly even points, but we do want to look at the similarities between the two smaller triangles and the large right triangle. So let's go ahead and let's label them. We're going to put C here, A, B, and I'm going to call this D. So we have three triangles, triangle ACB or ABC. So the big triangle, correct? And I'm going to always draw my right angles in the bottom left corner for this purpose. So we had A up here and C down here. Okay? And then, whoops, and then B. And we had the right triangle with D here. So we have D, B, and C, right? And then we had our other right triangle. We'll call it the medium-sized triangle. D, A, and C. So I purposely put my right angles here. I also purposely rotated it so that because A was at the top, A was at the top. Because B was at the right, B was at the right, respectively. So let's mark all of our angle A's in one color. And all of our angle B's in one color. Okay, so by angle-angle similarity, the small triangle is similar to the big triangle. Also by angle-angle similarity, the medium-sized triangle is related to the big triangle. And therefore, we could also figure out that yes, the other angles are also, these triangles are also going to be similar. Because if this is similar to this and this is similar to this, then these must be similar as well. Okay? So by angle-angle similarity, they're all three. Two of the three are, the small ones are congruent to the big one, and then transitive property makes the others similar, which means we have proportions. Okay? So that's going to be really important here. So let's go ahead and let's write those triangle similarity statements. So we have triangle A, B, C, right? And triangle ABC is going to be similar to triangle. And remember we had, since I did ABC, I need to do triangle CBD so that the green one was second and the 90 degree was third. I also have triangle ABC is similar to triangle. Now, remember I did the pink to the other acute to the right angle. So the pink to the other acute to the right angle. Okay? So I compared the big to the littles by similarity statements. So now I'm going to write that transitive property there for where we know triangle CBD is similar to triangle ACD. Okay, so let's write those similar statements. Let's look at the three segments. Okay, we have segment CB would be compared to AC. CD would be similar to AD, and BD would be similar to CD. And so therefore the ratios would be congruent. I want to really look at the segment that contains this CD. Okay, I want to look at the two ratios that have CD because CD is a shared side between the little triangle and the medium-sized triangle. So I'm not really worried about the first two. So I'm going to rewrite this statement up high. That way we can see it right next to where the triangles are written together. CD, AD, BD, and CD. Okay. So I'm going to give these names. Let's call this one X, Y, and Z. So CD I have labeled as Z, AD I have labeled as Y, BD I have labeled as X, and CD I have labeled as Z again. So if I do the proportion here, I'd have Z squared equals X times Y. Now, you notice that X and Y make up the hypotenuse of the whole right triangle, and Z was that split line. This proportion is going to happen every time, and it's known as the geometric mean. Okay, so let's go ahead and draw a nice little picture of that. So we have our right triangle. Okay, we have this coming in over here. We'll call this X, this A, and this B. So A is to X as X is to B. Okay, so leg part of triangle 1 to the altitude equals the altitude compared to the leg part of triangle 2, if you want. Or you can just remember A over X. So that's always going to be the relationship between the altitude of a right triangle on the hypotenuse side. It's going to be the geometric mean every single time. So they're going to give you pictures, and they're going to draw an altitude. Sometimes their drawings are much, much better than mine. If this is 5 and this is 15, could you find that? So we would just say 5 is to X as X is to 15. Cross products. Okay, so to get rid of squaring, we're going to need the square root button. If your teacher allows rounding, go ahead and just type that into the calculator. And you're going to just need to use the background button right here. And then 75, but it's a decimal. And the calculator eventually rounds. Even if you write all the decimals down, that calculator is rounded. So if you're in my classroom, we don't generally round because we want exact answers. So we're going to go ahead and remember that 75 is 3 times 25, and 25 is 5 squared. So we can either think of it like that, or we can think of it like this, depending on whether or not you like to utilize the rules or you like folding socks. Fold the pair of socks together, put them away. Your laundry basket still has a 3. Or root 3 times root 5 squared. The radical and the power cancel, and so the 5 is by itself and the 3 is still underneath. Either way, this is a much better answer. So make sure that you also keep that in mind. Now, what if we're not looking at that relationship? Could we look at a relationship between, bring our picture back, instead of looking at these in comparison to this, could we look at a leg and the altitude compared to the entire triangle in this? And the answer to that is absolutely. Or you can look at it here to here. That's actually a much better way. It's just good to write down your triangle similarities points so that you can always compare what you want to compare. So I'll draw this here. Okay, and I'm going to do one in pencil, that way I can highlight better. What if you're wanting to use the entire hypotenuse instead of the separated hypotenuse? Okay, so you're comparing the big triangle to the small triangles. So keep in mind, this entire thing is the hypotenuse. And it has respective legs, right? It has the short leg and the long leg. Let's say we're looking at this triangle here. Okay. This is its hypotenuse. But it's the long leg of the big triangle, right? So hypotenuse to long leg. Okay, A to X. So that was thinking big triangle. So in the little triangle that's shaded, the hypotenuse is X, and the longer leg is right here. Still a geometric mean, right? So what if we talk about the entire hypotenuse here? Okay, compared to, let's do this triangle. Okay, so if A is the hypotenuse there, we'll call X the hypotenuse here. But X is the short leg this time. So A is to X. So on this little triangle, we would need the short leg. Hypotenuse to short leg. So we can do the smaller triangles comparatively to that. Okay, so make sure that you are careful. As long as you line up your corresponding parts, you should have a great geometric mean popping out, and it should allow you to find these relationships inside the right triangle without a hitch. All right, so let's do an example here so that we get a few numbers. I'm going to draw weird. Okay, so here we see a triangle that has a 90-degree angle, and the altitude from that 90-degree angle has been drawn. So this tells us that in this scenario, we have our three different geometric means we can do. We can either do the geometric means between the two small triangles, the biggest triangle and the medium one, or the biggest triangle and the tiny one. So let's first look at the two small triangles. Okay, so remember with the two small triangles, if we look at this one, we have the two legs because this part here is where they make the L. So with the two small triangles, we're making that ratio between the long leg and the short leg. Okay, so we can see that the long leg of the medium is X plus 5, and that is to 6. And so that would be long to short. So this to this, long to short, this to this, long to short, where that altitude right there got used both times. That's very important. Okay, so we can use now the biggest triangle to the medium-sized triangle. So that means we're going to need to use our hypotenuse and our leg that they are looking at. So in both case, in the case of this triangle, remember our 90-degree angle is right here, so our hypotenuse is Z. And our long leg is X plus 5. Okay, so keep that in mind. We have Z and x plus 5. Okay, but here the hypotenuse is the entire 2x plus 5. And our long leg is z. Okay, and then we have our big to small. Okay, so we're going to have our hypotenuse of each of them respectively. So remember, y is the hypotenuse of the one, but it's the leg of the other. So that's the one that's getting used in both triangles. So the big and the small, they share y, so that's the one that's getting used twice. So we're going hypotenuse to small leg. Okay. So the hypotenuse of the small is y, and its small leg is x. The hypotenuse of the whole thing is 2x plus 5, and of the whole thing, the shorter leg, keep in mind we're looking at the outline, y is the shorter leg. So y is what got shared, so y is that double thing. So if you notice, these two share the 6. The big and the little share the z, or the medium share the z, and the big and the little share the y. So it's that shared component that winds up twice. And that's really what helps us out with this. Okay, from there it's just an algebra problem, so we're just cross-producting. I don't like these these two right now because they have multiple variables, whereas the proportion in pink just has the one. So let's cross-product. X squared plus 5x equals 36. It's quadratic, so I'm going to make it equal 0. And then from here, well, I know you could quad formula. I'm going to factor. Pull back your Algebra 1 skills. Best way to solve these and to keep up and prep for higher algebra classes is to just use your factoring anytime you get a chance. If you don't remember how to factor, go back, watch my factoring videos. It's a great thing. So we're going to reverse that FOIL process. So we've got x times x, and then we're trying to get to negative 36, but have the outside and inside make a positive 5. So that's why I'm going to pick positive 9 and negative 4. And now we're going to apply that zero product property, setting each of these equal to 0, because that's the only way to equal 0 is if one of the parentheses is 0. So we're getting 2 answers. I really don't want 2 answers for x, I just want 1. Well, x is sitting right here, and x has length, so x cannot be negative. So this one's extraneous. And we find out that x is 4. So if x equals 4, this equals 9. That helps us out because now if x is 4, 2 times 4 is 8, plus 5 is 13. And 4 plus 5 is 9. And in orange, we'd have the 13. And we'd have just the x. Okay, that cleans those two up so much because now we're down to a single variable. So we can cross product. Z squared is going to equal whatever 9 times 13 is. I know I could multiply it. There's a reason why I'm not. And over here, y squared equals 13 times 4. Okay, so to get rid of that squared power in both of those instances, we're going to square root. And I could get the decimal out of the calculator, but my class, I like to keep exact answers, trying to prep you for future math classes. Anyone can type it in a calculator and get the answer that's rounded. However, I want us prepped for future math classes. So z, we're going to do exact answers. The square root of 9 is 3. And 13 is a prime number, so we really can't do anything with it. Over here, the square root of 4 is 2. And had we not been able to just do it that way, we would have went ahead for a prime factorization to help us to be able to do the same thing. And we went ahead and reduced it down. Always try to reduce your radicals and leave an exact form, because now, as long as you know how to do that, yes, the square root of 9 times 13 is 10 point, but so is this. So you can always type it in a calculator, but reducing radicals is a great review. So make sure you're keeping your legs and hypotenuses straight. Make sure you're comparing apples to apples kind of thing. As long as you're comparing apples to apples and keeping these straight, you should be a rock star. Remember, the shared part is what gets put here and here. So they shared the 6, they shared the z, they shared the y. Anytime you're doing geometric means, one diagonal should have a duplicate. So one numerator and one denominator should be the same. And when you have an equal sign in between, you're allowed to do those cross products. So keeping those things together and keeping them organized will keep you on the path to be able to solve these things.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.